Hey guys, this is Menak and today we'll design a building using response spectrum method and we will use joint weight. And the previous video we had done joint weight and we had done a static analysis, and this will go a step further and we'll do the response spectrum analysis. As you know, all the buildings higher than zone 2 have to be compulsorily designed by response spectrum analysis as per the IS code. So this is very important method, so let's go ahead. So this is the building which is already designed by some other contractor. So we'll check this whether this design is okay or not as per after completing the design, and also we'll see the steps of the response spectrum analysis. So if you want to see the static analysis, then you can check the previous video, and I'll also provide some study materials or downloadable materials for free in this video links description. Do check that, and this will help you to make your process of working in STAAD faster. Okay, so let's go ahead. First of all, we'll make the stat file here, and this will be created the stat file. So we have to insert the coordinates here. First of all, we'll go to our plan. So as you can see, we'll just consider the main columns here to roughly check here. And as you can see, I have marked the coordinates. Before marking the coordinates and knowing the process, you need to know the if you go to stat, and if you go to view, and if you go to your top view, you can see this x is in this direction and positive z is in this direction. So positive x and z or x and z you need to know, and after that only you can mark the coordinates here. And I've converted this feet into meter and I have written the coordinates here. You can take a screenshot of it and you can proceed further. Okay, so let's insert the coordinates one by one into the STAAD Pro. And remember, the y coordinate is the height length. So if you consider the plinth level at 0, so it will be 0. So let's consider the plinth level at 0 and y will be 0, and let's insert all the coordinates one by one. Okay, so as you can see, the coordinates have been inserted. You can just match with this plan just to see whether everything is okay or not. And after that, just you go to geometry and click on add beams, and we'll join the beams like this. Okay, so once the beams are joined, this is the plinth level, so we'll go to select, and we'll go to node cursor. So node cursor will select all the nodes here, and we from proper view can go to the isometric view here, and we'll use the translation repeat options here to extrude back to the foundation level. So y direction, and this will spacing will be minus, let's take minus 1.9, 1.5 for the foundation and 0.4 for the plinth. Let's take this value, and we'll use the link step options and just click on OK. So this is the foundation level and this is the plinth level. So now we will just move on to the front view. Click on escape to move back to normal beam cursor, and select this. After selecting this, we'll go to geometry, and we'll use the option of translation repeat here, and for y direction, and we'll give the 3 meters and 2 number of floors here, and then click on link steps and then click on OK. So the topmost floor has some options, so we'll just select this and right click and click on new view. Okay, click on OK, and then we'll go to view and go to top view. So we'll see in the plan which portion has the open terrace. So this portion and the staircase portion has the plan. So select this first, and press control and then select this. So these areas selected, and then we'll go to the isometric view, again geometry, and then translation repeat, y direction 3 meters single step. Okay, click on link steps and then click on OK. So this is done, and you can see the whole structure here, and then you can go to the properties. Okay, so for the properties, let's define the beams, the columns and beams. For beams in this drawing, it has not been defined, so let's define the columns first according to this drawing. So according to this drawing, the columns are of two sizes here, approximately two sizes, which is 250 into 300 and 300 into 350. So C1 and C2 are to one size, and C3 is the higher size. Okay, so let's see whether this size is okay for this building or not. Okay, so let's go ahead, and first of all we'll do 250 into 300 to go with. So it will be 250 and it will be 0.3. Let's add this first, and the second variant you can see is C2, that is 300 into 250. I think there is only one here, so just add this 300 into 250 for this orientation change for this column. Okay, done. And then we have C3, this orientation. There are two C3, two different orientation. This will be of 350 into 300, this one. Okay, 350 into 300, this will be 350 into 300. Add this, and the next one will be 300 into 350. Add this and close. So firstly we'll go to the top view to do this, and the first value we'll see here. Sorry, just select this again, go to top view again. Okay, and first value for this 250 to 300, 1, this. So you can see all these columns will do like this except this C3. Okay, 1 2 3 4 5 6 7 8 9 columns will do like this. So let us see, 1 and 2 3 and 4 5 and 6 and 7 8 9. Assign, yes. I will check whether we have done justice or not. Okay, so C1 C2 there is same size, so we think we have done justice to this. And then there is the second option. For this there is only one column here, and then assigned and yes. And for this there is this column, assigned and yes, and for this there is this column, assigned and yes. So once this is done, so the property assignment is done. You can just see in the 3D view, you can see the property assignment of the columns here. So now let's do for the beams here. So we'll just define for the beams rectangle. We'll go with 250, 0.25 into 0.35 and go for this in all of the beams. So we'll just select and select parallel to X and parallel to, okay, we have not selected anything. We'll select first and then go parallel to X, parallel to Z, and then assign and yes. And then let's go to the front view. After that we'll go to materials. The materials already concrete, everything has been assigned. Go to support directly and create a support, fix support, and click on add and select this and select this support first. After that select the base, assign and yes. Okay, you can see in the 3D view that all have been assigned fixed support. So now moving on to the loading part, we'll go to loading here and firstly define the dead load, live load and the load combination for defining the seismic mass source. So first of all we'll add, let's go number 3. First we'll apply 2 earthquake load, so that's why 3 dead load, and then we'll go DL, just name this DL, click on add, and then we'll go 4, and then it will be live load, and we'll call this LL and add. So simply dead load, let's add the possible dead loads here. So help it will obviously be there, and the member load. Now for the member load we'll calculate this. The building height is 3 meter. Okay, deducting the beam, let's take 2.7 meter. Okay, so into thickness of the wall into unit weight, let's consider 20, so it is coming as 13.5, so minus 13.5, and click on add and close this. So another one, let's add for the plinth as well, sorry not plinth, parapet wall as well. Let's add minus 3 for the parapet walls, click on add, and also let's add a floor load for the floor finish tiles. So minus 0.5 will add, range will give, will not take it at pin level, so 1.1. the building maximum height is 9 meters, so 9.2. so we'll add this, and we can just add the slab self weight in this as well. So considering 150 mm slab into 25, so it is 3.7. Let's take 4 4 for this and this, so total 4.5. let's consider here 4.5. Click on add and close. In the top there will be the tank. In the topmost floor there will be the water tank, so let's add the load of the water tank also here. So add here, and area load, or you can just add flow load also, minus 10 on the top. So minimum give 8.8, maximum 9.2 only in the top floor. Okay, so each floor is 3 meters, so that's why. So this will be 3, 6 and 9. Okay, so we like this. Click on add and click on close. So you can see this is applied here. Okay, so after that self weight you can assign to view, assign, and yes. 13.5 you can just go here and 13.5 select this and press Ctrl and select this, and first of all assign this like this. Okay, now these two floors let's select and right click and go to new view. Okay, and you'll see what to do with this. Okay, let's go here and select, just move this a little bit so that you can understand. So parapet wall, we just load the select here, -3. So here will be a parapet wall. On press Ctrl, you load timber along the boundary. Periphery, make sure you have the parapet wall here like this. In the water tank also, this water tank is here, so here also we'll apply the load of the parapet wall. Okay, and click on assign and click on yes. Okay, and in this particular part we can apply the normal load of the wall. Okay. It will be for 13.5, right? Another one, let's select and then assign to selected view, assign and yes. Now similarly live load, let's add live load. This will be flow load and pressure. Live load residential building 2, apart from the plinth level, we'll just do everywhere, so range is within that, and close this. So live load has been assigned and dead load has been assigned. Okay, live load and the dead loads have been assigned. Now let's add the load combination for seismic mass source. So load combination for the seismic mass source, define combination. Dead load full will be taken as per table number 10 IS code. IS code table number 10, live load 50% will be taken if it is 3 or more than 3, and less than 3 25%. And this is a seismic mass, and you can see the definition of the seismic mass or seismic weight as well. Total dead load and appropriate amount of live load. So appropriate amount of live load will be get from this table number 10. So live load, for the live load it is 0.25. Add this, and the load number can be anything right now, but let's take 6. Okay, and click on add and close. So now what we'll do for getting the joint reaction, we need to do something. Select this and go to supports, and not this support, create a new pin support here. Pin support has been created, and select the pin support and assign the pin support here, assign and yes. So once the pin support has been assigned, then you go to analysis and design, analysis commands. Okay, and click on add and click on close. So after you do this, just click on run analysis to see the analysis file. There is no warning, so we are good to go. So the analysis has been completed. So once the analysis is done, we can go to the post processing mode and only select the load combination. Send this, there combinations there, only the load combination for the service load. Click on apply and click on OK. Now right click on this file and just click on your support reaction table. Single click on this particular table and wait for some time. Okay, so waiting for this will give you the selection depending upon your computer speed. Okay, so then after this selected, right click and click on copy. So once you have copied, move to your spreadsheet program. So in your spreadsheet program, enter the data. So first of all, what first thing it will do, delete the moments. These are not required. And since we have applied only the dead and live loads, which are applied from top to bottom, you can see the major forces are in the direction of Fy, that is acting from top to bottom. So this is also not required. So delete this and delete this. Okay. So after this, these things are deleted. Now here you write weight, WEIGHT. You can also download my format from here, and you can check here in the seismic definition we have to write weight. Okay, so first there will be node number and then there will be weight. So just drag this down to check the weight. Now for this also not required right now. For this also just Ctrl plus X, here Ctrl plus V. So you can see in this format, which you can download for free, is in the description. So this, the weight is given, and for defining the seismic mass you have to define the joint weight like this in this format. So no worries, we have achieved that. And now if you go below, another time you have to define the seismic response in the response spectrum. When you define the response spectrum, this thing loads, then you have to define it here also. So this fx and fz you need to define in two directions. You can define this is enough. Okay, so here you need to do like this, fx and then fz, both the lateral directions. So first of all, copy the node number. Okay, paste it here, and then you go in capital letters, write fx. So okay, drag this to the bottom. So fx is done. Now copy this and paste it here, and again paste it here also, leaving one. Copy this, you have to copy this again, paste it here also, leaving one gap. Now this you write fz. Okay, and drag it. So this was for the second portion. Okay, so this is done. Now what we'll do, we'll just simply go to the, it's very easy process, we'll simply go to the command file. So once we go to the command file, we'll just zoom in. Okay, and after we zoom in, we will do this, we'll look into this command file, and we can, the supports which were pinned, we'll just make this option as will uncomment or comment. So this will be normal again. Okay, so then you can define this code in the directly using this also you can do, or you can do this using the STAAD itself as well. Okay, so let's see. So just I'll just do it using STAAD for your, just click on check syntax. After this is ready, no error found, just close this. Okay, now nothing is pinned. Now I'll go to our loading definition, seismic definition, click on add, and here we will just use this criteria 2016 code. If you are using the older version, you can use 2002. Click on generate, and here we'll use the zones. Bhubaneswar is in zone 3, but the building is located, and special moment resisting frame, importance factor 1 for residential buildings, and this will be medium soil and damping ratio 5%. Foundation depth take as 1.5 meter. Period in X and period in Z I have already calculated as per the code, and I will just show you the clause. You can check this out for yourself. This clause number is 7.6.2, so it's 0.32 and 0.25. So I'll just insert this here, 0. Or you can just take program calculated if you want approximate also. Okay, so just check out this clause. Now I'll just click on generate here and add, and then close this. Remaining will add in STAAD editor itself. Okay, if you want to check out this clause, if you have any doubt, you can ask me in the comments. I'll make a separate video on this, but it's very simple. This is H is the building height, which you take as the height of the building plus the plinth height, and then X and Z are the lengths in two directions. You can see this is approximately 7 and this is approximately 11, so that's why this is taken. I can calculate and easily find out. Okay, so once this is done, remaining thing we'll do in the STAAD editor. So in this load case, we can add directly in the stat editor as well. Here also we can add our seismic loads or response spectrum loads we can add. Okay, so let's just add a primary load. Here you can see there is options of seismic load as well. Okay, but we are adding response spectrum load, so just click on none. Okay, and here you can just check the format here. So this in X direction, X response spectrum, you can just name this title here, X response spectrum, title X response spectrum, and then click on add. Okay, close this. Okay, oh sorry, this is not under this, delete this. Yes, in load cases go and click on add, and then click on this none and paste it X response spectrum and click on add. Okay, so okay, this is coming under this. No, I want outside. If I add it here, then it comes under let live load, which I don't want. Okay, I'll delete this and simply add in editor itself. Simply I wanted to show you, that's why. Okay, no problem. So we'll go to the command file. Okay, go to the command file here, and here first of all the load combination which we had created to just show this combination, also make this as comment, because this combination is not required now. Okay, now using my file, okay, you can just add the load type 1 here, load type 1, response spectrum joint load, and in this joint load you can add on the Excel file. Okay, take the Excel file and you can add it using this Ctrl+C and Ctrl+V. Okay, once this is added, then you can go to the file which you can see. I'll explain all of this, how this is done. Okay, simply copy this, you copy X, okay, X, and again you copy, just to give some space here, load 2, okay, so I'll type 2. Okay, just you can give some stars just to keep some space. Okay, these two are defined. Now let's okay, we'll just modify this later, but let's finish the copy paste first. Okay, so we'll go up, and in the seismic mass which you've defined here, okay, here we'll define the, you can see in this format what is here. This is joint load, joint loads, joint weights here, so which you have already prepared in the Excel. Okay, for here, so just copy this, copy, and paste it here. Okay, this is done, and now let's come back here to the explanation of this. So this is the CQC, this is the method. Okay, mathematical method, and IS 189/2016 is the code, and TOR-X and acceleration scale. So acceleration scale will be 1 here, just simply take as 1. This is the acceleration scale for STAAD Pro. If you use other units, just you can take this as 1. Damping ratio is 5%, and TOR-X and TOR-Y I'll just explain. Soil type 2 is medium soil. Okay, medium hard, 1 is hard soil, 2 is medium soil, and 3 is soft soil. Okay, now TOR-X value, just you go to the IS code here, and you can go to the clause number. I have just taken a screenshot of this. You can see clause number 6.4.2. Using this you can quickly calculate the torque value. So this is actually Z by 2. Z is seismic zone factor, and for zone 3 is given in table number 3. It is 0.16. So that value we got by 2. Now R is for special movement resisting frame. R is 5, and I for this building is 1. Okay, so this you can get using these tables. You can always get the R is 5 for this, importance factor on table number 8, response ratio on table number 9. You can get this, and now comes the final thing, SA by G. So how we find SA by G? So in this clause, in this clause number B, you can see this is for response spectrum method, and there are 3 soil. So ours is medium swell. Now you have to know the time period. So if you just take assume that it is 0.5, then we'll take as 2.5. so if you take as 2.5, the value comes to around 0.04. so we can just take 0.04 here and scale 1. Okay, so this we can take here from this, and simply just press Ctrl plus S, and don't forget to check syntax. So if there is any major error in the check syntax command, it will show. Okay. Oh, okay, so yeah, there was an error here. I think in this, after this we have missed the thing. Okay, that's why this check is so important. After this, you can see cutoff mode shape we have missed. So cutoff mode shape, you can give an approximate value, and after that you can increase or decrease it also. Let's give 135. Okay, let's give 120 for now. 120 let's give. Okay, so you can later change this also, and let's again the check syntax. Again we have missed something. You can see joint weight command we have not inserted. Okay, so we have missed that. So simply just copy this joint weight, Ctrl plus C, and here after this paste it here, Ctrl plus P, and then check syntax once again. So now this is okay. So there is only Ctrl plus S and check syntax once again. There is one error. Node 1 is 318 is not found. Okay, so it is removed from list. So there must be, okay, or 318 it was earlier. So okay, just remove this 318. I'll copy paste this error had occurred. Okay, Ctrl plus S, and again check syntax. No error has been found. So there are some errors while copying and pasting, so that's why this thing occurred. Now there is no error. Okay, so once there is no error, you can just close the file, and after closing the file you can simply run the analysis first. Run analysis, and then we'll design later. First let's see if there is any error. So there is one error you can see. Let's see what is the error here. Okay, so we haven't add analysis, that's why this error is there. Erroneous data, that's why this is occurs. So just delete the command of perform analysis, and then again we'll add analysis again of all, and click on add and close, and then run analysis once again. So now there is no error. Okay, so the structure has been analyzed fully, no error. Let's check the loading first. So that's the most important thing. Okay, seismic definition, you can see this is the joint weights which has been defined in the seismic mass. The joint weights have been defined, joint weight method, and here we go. And in this, let us first of all close this definition. Let's totally close this. Response spectrum X direction, you can see in two direction the load is applied everywhere. Okay, and response spectrum CQC method, you can also see if you insert by this, you can see this is the IS 2016 method is CQC, mathematical method for calculation. This STAAD Pro scale is 1, and this value is also here. Same thing you can apply in all the direction. This is in X direction, and if you just check here, this is supposed to be Z response spectrum. Actually we have to actually change this. So this is in Y direction, but this should be in Z direction. Okay, so you can see this should be in Z direction actually. Okay, Fx and Fz. So we'll edit this in the STAAD editor, I think. So we'll go to edit command file, and here just mention to do this as Z, and this will be toward Z. Okay, and remaining things are okay. Just press Ctrl plus S and then close this. So now we go to loading, and then you just check this response spectrum load. This is okay, this is in the Z direction. Now everything is good, and here also you find the loads which are acting in the X and Z. it is acting. So this is good. Now you go to load case detail and you can add the load combination, the auto load combination. Just add from the IS code 456. Okay, select starting. Okay, just before load combination, just see whether all the 1 2 3 and 4. Okay, 1 2 3 and 4. Now click on add. The 4 load combination in serial number I've just checked. Okay, so click on add. Okay, add auto load combination. Select the code once again, IS 456 to 800. Table generate loads. Now click on selected loads are there. Click on add, and then you can see this is 1.5 into load 3 and load 4, 1.2 into load 3, and 1.2 into load 4, and you can see 1.5 into load 3 and 0.9 into load 3. So you can see the load combinations which are generated by auto load combination using this are not appropriate. You can see this 1.2 into load 3, so this proper is not done. So I'll customize it for you. Okay, first, and then you can insert this. Okay, you can come up to this file and simply copy this from service load and strength load case, and if you want envelope also. Okay, just some minor modification needed. Okay, so now you can copy, start from here, and service load this one. Okay, this one also, from here also you can copy if you already find envelope. Okay, simply copy this and go here, go to the command file, and in here look for the load combinations. First of all, just delete this load combination here, from here. Okay, load combination 5 is starting, delete here, and perform analysis print all is good, just paste it here. Okay, so this is done, and then press Ctrl plus S and check syntax. So it will check processing completed, and if there is any error it will show. Okay, load type 5, there is an error in this file which I have copied. Okay, let me check. Okay, so this will not be 5. I'll just modify and change this. This will actually not be 5. This will be 1.1 integrator plus library will be 4 actually. I'll just change it before uploading for you guys. Okay, so let me again check syntax. So possible typing error. This is okay. Yeah, this line came twice, so I have to delete this as well. Okay, I'll just share the corrected version with you. Check syntax. So now there is no error, so I'll just copy this and do the corrected version with you. Okay, now simply Ctrl plus S, save this file. Okay, wait for some time, otherwise sometimes some problems come, then close this. So once this is saved, and then you go and license the design and run analysis and check if there is any error or warnings. So 2 warnings by default they are there, so let's see the output file and see what those warnings are. They're not much serious. Okay, what is the warnings? So yes, rigid diaphragm we have not defined, that's because we not considered slab. And now multiple eigenvalues solutions are there. So let's see the mass participating factors, 54, and it is comes firstly some of this should be minimum 65%, so it is okay. So this is okay for now, this is okay. And let's see the messages. Okay, this is Okay, so there are, you can see in this message, number of modes requested 120, number of existing modes in the model 88, 88. So we give more, then there is no error. So now you can change the cutoff mode as well. You can go to utilities and go to command file, and you can change this as well, this cutoff mode shape which you have defined as to 88. So no problems in that. Just save, check syntax, and before there's no error found, one message, no error found, just close this. Okay, so now what we'll do, we'll just go to design, and let's design and see the checks here. So first of all, we will go and select concrete, and let's select the IS code here. Select parameters. What parameters do you want to select? Let's only select the concrete because anyway the remaining parameters they take automatically. So only concrete. Define parameters. We'll see. Let's define M30, 30, 1, 2, 3, and then click on add, and then close, and then commands. In commands you'll go design beam, design column. That's it. So first of all, M30 assign to view, assign yes, design beam, and select parallel to X, parallel to Z, and assign and yes. Design column parallel to Y, assign and yes. This is done. Analysis and design, run analysis, save, and the analysis will run. Let's check the design process here. So there are two warnings, means all the members have passed. Okay, two warnings are from earlier. So you can see 816 bars are there, and here 12 bars, 420 bars. Okay, this particular column has 420 bars. So let's check the design here. Design for this maximum. So 616 bars are there, and 420 bars, if you see 616 bars, 616 to 200, approximately 1200, 4 into 3, 14, 1200. So it is okay, it is close. So the design is okay for now, and for the beam is also okay. Beam also, the design was not given. So this default design you can see here, 410 is coming here. Let's see where some loads are. So the design is 316. Okay, so 316 on in this size should be the appropriate amount. So this you can see response vector analysis was done for this structure, and it was analyzed, and you can see the results are pretty much there. And you can see say this particular file, in this particular file the sizes of columns and beams are not given, so columns are safe, and the reinforcement is also pretty much okay. So that's how we check, and check whenever someone gives you a structure, you can check that. And you can also check the foundation in RCDC, but the soil test report is not available, so accurately you cannot do. But if you have the soil test report, you can check the foundation design in RCDC as well. So that's all. Thanks for learning. Bye bye.